In this video, we are going to be covering some examples from our first week of statics, which introduced vector force systems, as well as reintroducing us to some geometry concepts such as cosine law and sine law, and the decomposition and addition of vectors and other vector operations. So today we're going to put those to use, and we are going to solve a couple questions from our sample problems. So let's go through it together. Our first question is asking us if the resultant force is required to be directed in the positive x-axis. So let's draw that right now. Fr. And Fb is required to be a minimum. Determine the magnitude of Fr, Fb, and the angle that Fb makes with the x-axis. So right off the bat, there's a lot of things going on, lots of unknowns happening. So what to do with this question? So the first thing I would do is decompose our Fa and Fb. So some important things to consider. We know that the resultant force is going to be directed in the positive x direction. So that means our sum of our y forces is equal to 0, because we don't want our resultant to have a y component, because that would deflect it in a diagonal direction, but we want it to remain just in the x plane. Right? So those are a couple important things to consider. So let's start with color. Start with Fa. It's 2 kilonewtons. So Fax equals, that's 2 kilonewtons. That will be 2 kilonewtons times cos of 30, and Fay equals 2 sine 30. Then for Fb, we will have two unknowns. So I have Fb cos theta in our x direction, and Fby is Fb sine theta. So then when we add these up, so our sum of our x components is equal to 2 cos 30 plus Fb cos theta. Right, and we don't know what that equals, but we do know that our sum of Fy forces is equal to 0. So then we can rearrange for this equation. So I'm just going to zoom in and draw the x and y components so you guys can see a little better. Right, so we know for Fa, we have positive x, positive y direction for our components, and for Fb, we have negative y, positive x direction. So, sorry, forgot to say that earlier when I was writing out the sums of them. So they have both positive direction, right? So like we said, for Fay, it's positive, and our y direction in our Fb is negative. Negative Fb sine theta. So step 2 is to look at this equation right here. So we're going to take a look at this one because we can actually solve and isolate for our Fb. So when we rearrange, for that, that will give Fb sine theta equals 2 sine 30. And then that will be Fb's equal to 2 2 sine 30 sine theta. So our next step definitely helps if you use a calculus approach. So we want to minimize our force of FB, right? Because we wanted FB to be a minimum in this question. So in that case, we can solve for that by taking derivative of FB. So if we took the derivative of FB, our unknown is our theta, so that is what we are going to be differentiating with respect to. That's 2 sine 30 and then that's times sine to the negative 1. This is just a constant, so I'm going to kick that out. So that gives 2 sine 30 on the outside. And when we derive this, this is chain rule, so this comes to the front, so that's negative 1. What's inside stays the same, reduce the exponent by 1, and then multiply it by the derivative of what is inside the brackets. Right, sorry, this is equal to 0 when we take the derivative. So this will be 0 equals negative 2 sine 30, and that's cos over sine squared theta. Right, so then looking at this, we can move some of these terms over. So when we multiply this to move over, that still is 0, so that's 0 equals negative 2 sine 30 cos. And when we take this term and divide it to the other side, then that also turns into 0. So then we have 0 equals cos theta, which means theta is equal to 90 degrees. So now that we found our the angle that would minimize B, FB, we can find FB and FR. So let's use this equation again. And that will be FB equals 2 sine 30 over sine 90, which is just 1. So then that gives 2 sine 30, which is just 1 kilonewton. And we know that our angle is 90 degrees, so that means it's going to be directed downwards, like that. Okay, so our sum of fx equals 2 cos 30 plus 1 cos 90. And that is, cos 90 is just 0, so that is also just 2 cos 30, which is 1.73, 205. And then we know our sum of fy is 0. So when we take our resultant, it's just going to be this squared, which is just that number, once again, newtons. Right, those are our 3 answers. Let's check. Yep, those are right. Awesome. Okay. Next question is asking us, let's see, hold on. If the magnitude of the resultant force acting on the eye bolt is 600 newtons, so this is not depicted, and its direction is measured clockwise from the positive axis, so that should be important to consider, measured clockwise. for our angle. And that's 30. Determine the magnitude of F1 and the angle phi. Okay, all right. So we know our resultant force measured clockwise this way from the positive x-axis is 30 degrees. So that's halfway in between. This is 30 degrees. This is FR. We're looking for F1. Okay, so what I am going to do, I am going to break down all of these components, and we are going to work backwards. So let's try that out. So I'm going to start with F1. So we're going to keep F1 as a variable. Actually, hold on. We're going to do one more thing first before we move on. So the first thing I would do is I would take our break resultant into x and y components. So that way we can find what our sum of fx is and what our sum of fy is. So our f resultant of x is going to be equal to, so we have a resultant force, which is 600 newtons, and that will be cos 30 in the positive x direction. And for our y, it will be 600 sine 30, and it will be directed in the downward direction, or the negative y. So negative y right there. Okay, those will be our answers. So now, let's break up our other forces. So we're going to start with 450. So then that's F3x equals 450 newtons. And then that will be 3/5. And that is in our negative x direction. And our downward force, our y component, means that we have a negative y component as well. It's negative 450, and then that's 4/5. Just using the little triangle ratio that's given to us there. Next, we have our F2, which is equal to 500 cos 60 in our positive x direction. And then F2y is 500 sine 60 in our negative y direction, because we are pointing downwards. Okay, and now to write for F1. F1 equals, so we don't know what that angle is, so no worries, we will figure it out. Okay, so this is F1 cos, or positive x direction, and then F1y, positive f direction, sine phi. Okay, so a lot to process here, but it's not too difficult moving on. So in our equations, we are going to have two unknowns. So let's write out our sums. Okay, So we know that our sum of x is equal to 600 cos 30 equals minus 450, 3 over 5, plus 500 cos 60, and then plus f1 sine phi. So that's equation 1. Equation 2, going to have negative 600 cos 30 is equal to negative 450, 4 over 5, minus 500 sine 60, plus f1 sine phi. This is meant to be cos, sorry. So now we're going to isolate for our f1 terms. So that will give us for our x direction, that is 539.615, then f sine equal to, so negative 600 cos 30 plus 455 plus 500 sine 60, and this is 273.397. Now our fifth step, we want to make a tan ratio. So we know that tan is sine over cos, and we have our sine and our cos, but we have an unknown angle and an unknown force. So what we can do, we can put them over each other. So we can take f1 sine phi, f1 cos, equals 539.61. Nope, that's the wrong one. So sorry. 273.397. And this will be 539.615 equals tan phi. We'll see that these f1s are going to cancel out when we make them a ratio like this. So I know that tan phi is equal to 0.50665. And then when we take tan inverse, we know that our phi will be 26.869 degrees. Let's just check our answer. Ooh, I messed up. Okay, let's see. Let's see where we went wrong. Sorry, that was a small error on my part. That was just a math error. This is supposed to be sine, not cos. So that means this is going to be a different value. Okay, let's try that again. So negative 600 sine 30. That's plus 450, 4 over 5, plus 500 sine 60. There we go. So that gives us 493.012. That's what goes here. Here we go. 493.012. take this, divide it by, and this gives us 0.91363. Tan inverse of that. There we go. So that is 42.42 degrees. So that's our answer for phi. And then plug back in to find our F1. So find each F1 component separately. Oh, sorry. So now use these equations here. So this is 3 and 4. You can use the ones from step 4. F1 equals 5.39.615 over cos 42.42. That's equal to this is 730.921 newtons. And then our F, actually, yeah, no, that's it. That's it, sorry, because we don't need to find the other one. There we go. Magnitude of F1. Let's check our answer. Awesome. All right, so that's this question. So rule of thumb, if you have two unknowns when you isolate for your unknown terms and they're all grouped together, and you've got a cos and a sine one with the same angle, you can arrange it to make a tan ratio. So rather than having two unknowns with our sine cos, so rather than having three unknowns with our sine cos phi, we only have two, and then we can use trig rules to solve it. That'll be really helpful. Okay, problem 5. Okay, so the first thing that we're going to do with this question is we're going to draw what some of our forces are looking like. Okay. So, force acts on the frame such that the component acting along AB is 650 newtons, so just assume it's in tension. And we have another component acting along BC. So I'm just going to call this FBC. Set F to 850 newtons. This to 30 degrees. And we are looking for phi, and we are also looking for FBC. Okay, so a little bit more thinking to do with this question. Hopefully I'll be able to do it. If not, that will be embarrassing for me. So hopefully I can do that. So let's see what we're working with. Okay, so I'm going to draw, if we were to draw a straight line, tangent to B, we can imagine this line being parallel to this line over here. So that means the angle phi here is equal to angle phi over here. So this is phi right here, right? Because that's the angle that BA makes with the green line. Using the same rule of geometry, we know that, remember, FB makes a 45-degree angle with the straight line. So that means up here, we also have 45. I think we have enough to answer a couple things, or at least to get started. So we have 650, FB, FBA, and then this is FBC, which we don't know yet. And then as a resultant force, we have 850. Okay, some things we can label. We know that this is phi, 45, 30 degrees. Okay, so what can we do? We can find FBC using some simple cosine law. Right, so a couple other things we should note on here. Sorry it's so poorly drawn, but because this angle is 30, this angle is also 30, which means we have two unknown angles of alpha and beta. Okay, so if we were just to take a look at this triangle right here, we'd see that we have unknown length of FBC, but we have two known lengths of 650. So this 650 is parallel to this line here, so we can also consider that 650. And we want to find FB, right? And we have our given angles, so we can use cosine law. So let's do FBC. So side 1, 850 squared, side 2, 650 squared, minus 2, 650, 850 cos of our desired length, which is FBC, and whatever is across it, so we trace, and that's cos 30, giving FBC equal to just going to give 433.638 newtons. Okay, so we've solved for FBC, and now we need to solve for our phi. So a little bit more geometry up ahead, but that's okay, we can handle it. Probably. Okay. So now that we know FBC, we can do some sine law. So let's do, so what we do know is 850, which is across from sine alpha. And we also know FBC, which is a given number already, and that's across from sine 30. So let's see, that will give us, divide by sine 30, so that gives sine alpha equals 0.9800. That means alpha is equal to 78 degrees. But this can also be equal to 101.455 degrees, and that's because we need to consider if we had sine 80 minus a. So we are going to use this value because we can see that this is an obtuse angle, so that is what we're going to continue with. So next up, I think we need to find Yeah, let's see. Okay, so next on our list, we can use sine law for, I'm going to actually switch the order around. Use sine law to find our beta. So sine beta is across from 650, which equals FBC, nope, other way around. Sine 30 over FBC. Sine 30 divided by times 650. So that leaves sine beta equals 0.7494. And our beta angle is 48.5447 degrees. And now we can use this to find our angle phi. So the way I'm going to do this is sum all of the things here and make it equal to 180. So 80 equals phi plus 30 plus beta plus 45. So that means phi is equal to, see, so 180 minus 30 minus 45 minus beta, and phi is 56.46 degrees, which is correct according to our sample question. Okay, so our last and final question for this problem. Let's take a look. Two forces act on a screw eye. So if F1 is 400 newtons and F2 600 newtons, determine the angle between them so that the resultant force has a magnitude of 800 newtons. So let's draw where that magnitude, where the resultant force would come out of. So using parallelogram rule, use this method to find where it's going. And F resultant is directed this way. Okay, so first things first, we are going to split this into two different angles. We're going to call this one alpha, and this one color, let's see. And this one beta. Similarly, that means that the angle here is also beta, and the angle between our blue one and our resultant is also alpha. We have another one called gamma. Oh, sorry, and we also know our F resultant to be 80. Nope, 800. So we have all three of these lengths of a triangle, and we're missing all the angles. So we are going to be using cosine law for this. So let's see. So theta is equal to alpha plus beta. Then gamma is equal to 180 minus theta. So let's draw what this triangle looks like. So this is so we have our 600, our 400, and our 800. And the first thing I would like to solve for is our gamma. that a good idea? Hold on. No, I'm thinking. Is that what I want to do? Okay, let me consult. Okay, so first angle we are solving for is gamma. So using our cosine law. So that's length 800 equals 400 squared plus 600 squared. And then that's minus 2 400 times 600 cos. So that's going to give us, so that's 800 minus, oops, sorry, this is supposed to be squared as well. So 800 squared minus 400 squared minus 600 squared is negative 1200,000. So it's negative 2, actually let's solve this. 2 times 400 times 600, it's negative 40, oops. Then cos. Okay, so when we divide that, we get cos gamma equal to 0.25. Then that gives gamma equals to 75.5224. Right, so that is our first part. And now we can use sine law to find the rest. So let's do, let's do sine beta over 400 equals sine 75.52 over 800 sine b is equal to divided by 800 equals 0.4841, and then beta is equal to 28.955 degrees. And lastly, do sine law for alpha. So that gives sine A, sine alpha, equals 0.7261. And that gives alpha equal to 46.567 degrees. And we know that theta is the sum of those. So that means theta is equal to 75.5224. Right, and that is right. And that brings us to the end of our practice problems. Of course, there's a lot more questions you can practice with, but to review, we covered basics of sine law, cosine law, and decomposing different x and y components of forces when given resultant forces, or the forces that will add up to create a resultant force. We also talked about how to minimize a force by using derivatives. So I hope you enjoyed this video. I hope it helps, and I will see you in the next one.